Alright guys, we've been talking about inheritance and polymorphism. Remember, polymorphism is the ability to create different objects that appear to be the same to the program, but they respond differently to method calls. So you can create several different objects. They're all inherited from the same type, but their methods do something different even though the methods have the same name. And I did not realize that this chapter did not include interfaces, but abstract methods is a stepping stone away from interfaces. So we're going to hit the abstract methods and classes chapter or section, and then we're going to quickly probably go on to talk about exception handling. So I believe we did this. I believe we created some classes that we could add to an array or to an array list, and then we could rip through the array list calling the same method on it and getting different results based on the object. So abstract classes. What is an abstract class? An abstract class is one with methods that are not defined. You can declare a method to be abstract. What that means is that the method is just a dummy method, and then you have to override it later on in the subclass. So Java requires that you must define the method to be abstract. If you do that, you have to use a abstract method heading. You just got to stick the word abstract in front of the heading. Then the superclass also has to be declared as abstract. And then you have to override that method inside the subclasses. So let's go ahead and do that. Let's come up with a really simple little class that's going to be an abstract class. So go ahead and create your Java application. Once you get into it, the very first thing we want to do is to add another class called shape. So in my package, right click, add a Java class, a shape. This is going to be our superclass, but it's going to be an abstract superclass. And from shape, we're going to inherit we're going to derive a few subclasses, one called square and one called circle, our favorite examples. So, what do we want every shape to be able to do? We want to be able to calculate its area, because that's the most important thing in the universe. So if we were going to do this normally, we would do this: public double get area, and then we would have some code, right, that would calculate it. That's not going to work. We don't have any information in this class at all that could actually calculate get area. All we are saying is that all of the children are going to have a get area method. So all the subclasses will need a get area method. To do that, we have to describe that method as abstract. Once we add that keyword to a method, we have to declare the class is abstract. And once you declare a class as abstract, you don't put a method on it. And let's put another one called setName. Abstract public void setName. We're just going to take a string. Again, we can't implement this function here. We don't have a name instance variable in order for it to set it, but the subclasses are going to. So I'm going to put a comment here, what we are doing here. This is the superclass. It's for the geometric shapes, such as circle and square. And I'm going to go through and delete the package declarations as I spot them, which requires me to move them into the correct folder. I need to do that also with the main class, the client class. So I'm going to go back to it and do the same thing, delete. So this is the client class for the code for the project. All right, let's make a shape that extends the shape class. So I'm going to go back to my projects. Oh, when I deleted the package declaration, I forgot to move it into the correct package. Better do that now. Now I can go back to projects, go to the default package. I'm going to remove this package that doesn't have anything in it anymore. So right click on it and choose delete. Alright, so in the same package, in the same directory as the shape.java, we're going to create a circle. So Java class, name it circle, click finish. Now it no longer has a package. Good enough. And this extends shape. And immediately, if you notice, we get an error saying that circle is not abstract and does not override abstract methods. Now, if you mark this one as abstract, it wouldn't have, don't do this. If you mark that one as abstract, it wouldn't have to override those abstract methods that we put in the shape class. But the children class of this one would need to, the subclasses of this one. So I'm going to take that word off, and we're actually going to provide these two methods, getArea and setName. Now, what kind of data does a circle need? It needs a radius. So I don't care if it's private or public. Let's go ahead. Private, double radius. Let's provide a setter for it. Void set radius to a double, and its content is, of course, this dot radius equals to the radius parameter. Now that doesn't solve our conundrum about the abstract methods. We do need to implement our getArea. So the header needs to match exactly this one. We could just copy and paste that, you know, remove the abstract keyword, but otherwise it's got to be public double getArea. The area of a circle is pi r squared, so double area is equal to math times pi times radius. Return area. Now it wants us to add the @override notation, so I'm going to go ahead and do that. Above that, @ capital O, override. Very good. That gets that warning to go away. However, the class is not finished. If we scroll up here, we see that this line is still marked with an error because it does not override abstract method setName. We did handle one of the abstract methods right here in getArea, but we did not do a setName. setName implies that there's a name variable. So, private string name. And let's put a setter for that one. Public void setName string name, curly brace, this dot name equals name. Now it will compile. And again, it wants us to add, whoopsie, straight S here. It wants us to add the @override, not necessary. Helps the compiler double check things for you. All right, so that's our circle class, minus the ending brace. Pause if you need to. Guess I could take up some blank lines. Oh, that's not the entire class, right? All right, to make it fit, I'm going to do this. This dot name equals name, all on one line, like that. And then for the setter over here, this dot radius is equal to radius. That makes sense? With your closing brace after that. Alright, now it all fits on one screen. So pause as you need to get it in. So we have a circle class. We can use it. I'm going to go back to our client code and create a circle. Now we're probably going to want to add one more method to this. At least one. So far we're ignoring name, but if we had a toString method, then we could use the name. So maybe we'll go back and add a toString method. Yeah, let's add it right now. So public string toString string s is equal to the name plus the word space area equals plus get area, and then return s. There, at least we're using a name in something. And I am going to add the @override notation. @ capital O override. So that's our new method. Here's our two that we had to add because setName was abstract and getArea was abstract. So we had to have both of those. SetRadius we didn't have to have. Why? Because when we go and we create our square, it's not going to have a setRadius method. Setting the radius of a square makes no sense. All right, I'm going to go back to the client code. You good? Ready? Okay. So here I'm going to create a circle. Circle C1 is equal to new circle. The name of the circle, C1 dot set name to Bob the circle. C1 dot set radius. Circle has a radius of 10. Now here's what we want to be able to do. I'm going to go ahead and type it, but it's not going to work yet because we don't have a square class. Square S1 is equal to new square. S1 dot set name is equal to Sally the square, and S1 dot set radius. Except we're not going to have a set radius, we're going to set a side length. So set side. Going to have a side length of 10. Now obviously we don't have any of this stuff yet, so that's all errors. But the next thing we're going to do is we're going to go and create a square class that extends our abstract class shape and implements the methods necessary to get it to compile. Then we'll come back and we'll actually use it. We'll print out the squares and we'll call the area methods or whatever. So let's go back to our projects, and in the same folder as our circle class and shape class, same package, new Java class, square, finish.
Do the child classes inherit the instance methods too?
Yes,
Or
yes.
not methods, sorry, the variables.
Yes. A child class inherits variables as well. So we could have put the name variable inside the abstract class. That wouldn't have been a bad idea. But if we were going to do that, we probably wouldn't have made set name abstract. Set name could also have been part of the abstract class. So square class extends abstract shape class. Delete my name. Public class square extends shape. Immediately we're going to get our errors. Does not extend name. Okay, so we need two instance methods. Private string name. Private double side or side length, whatever we wanted to call it. I'm just going to call it side. And again, we need a set name and a get area methods. And we know this since we have a private variable named side, we also need to provide a setter for that. May as well take care of that first. Public void set name, string name, close parentheses, open curly braces, this dot name equals name, semicolon, close brace. Then I'm going to do the same thing for the side instance variable. Public void set side, string side, end parentheses, open curly brace, this dot side equals side, semicolon, close curly brace. And I spelled string wrong. I'll go back and fix that. Still spelled it wrong. There we go. Set side, side is a double, not a string, so I should not have been typing double in the first place. So the correct syntax of it, public void set side, parentheses, double space side, close parentheses, open brace, this dot side equals side, semicolon, close brace. Alright, it's really wanting us to add the @ override on set name because we are overriding. It is an override. So @ override. We're going to put that above our set name method, but not the set side method. Set side isn't an override. Now we're ready for get area. Area of a square is obviously just side times side. So public double get area, parentheses in parentheses, double area is equal to side times side, return area. Get area is an override of the abstract method, so I'm going to add the @ override on top of it. Of course, it'll compile fine without it. All right, now let's go ahead and provide our toString method. No, it's not a override. So public string toString. String s is equal to the name plus a space followed by the word area equals followed by a space. I'm not sure I formatted exactly the same on the other one. End quote plus get area. Return s. And as always, toString is an override because it gets that method from the object class, which is the superclass for every other object, for every other class. All right, I believe we have a good class. If we were going to follow our rules, I would add getters for the names as well as the setters. You know, data private, methods public, add getters and setters. Add toString, I've done that. Add a constructor, I did not. That'd be a nice thing to do. And add dot equals so that we can compare two of them to see if they are the same object, if they contain the same data. That's a more precise term. Alright, I'm going to scroll from the top to the bottom so you can verify your code. go back to our client. We're going to create a circle. No, we're not going to create a circle. We've already created a square, and notice that all of our errors went away because we've properly implemented it. Square is a subclass of our abstract class. It completely implemented all of the methods. One thing to note is that you cannot create an instance of an abstract class. If I tried to, I'd get an error. If I type this, shape, whatever, is equal to new shape, that's an error because shape is an abstract class and you cannot create an instance of an abstract class. So the error is shape is abstract, cannot be instantiated. But we can sure use it in arrays, or we can use it in array lists. Let's do an array list. So I'm going to go up to the top, add my import java.lowercase-util.uppercase array list.
So what would be the benefit of making
Yeah, why do you create an abstract class? Is so that you can enforce yourself or another developer, if they're creating another shape, to implement all the methods that your code is going to need. So you do that instead of creating like some dummy methods. We could have done a get area return 0 up at the top of it, but in that way everything that extends the shape class at least has access to a method even if it doesn't implement it, but we want to force them to implement it correctly. So that's why you create an abstract class. More generally, I'd say that you do it so that you can support polymorphism accurately in your code. You can create a set of classes that all abide by the same rules. They all have the same methods, and they are guaranteed to have the same methods. All right, let's create our array list. Array list shape list. I forgot to say that it was an array list of shapes. Array list angle brace shape space shape list is equal to new array list angle brace close open parentheses. I said that backwards. Open close parentheses open close. And we can start adding things to it. If we had a constructor, it'd be easier to add things, right? We just create the data as we go along. Maybe we'll go back and do that. So we already have a C1. We already have a circle one. We can just add it to our shape list. Shape list dot add our circle. Shape list dot add our square. Now let's just create code that'll go and print out those two guys. System.out.println. Let's just call this, say, printing shape list. And then why not a for each? So for parentheses, for every shape colon in the shape list. That's not right. For every shape S, E for element, something like that. And I'm messing up on capitalizing my L wherever required. For parentheses, capital S shape, E, colon, shape list, capitalized however you did it. We're going to print out that shape. We could print out E.toString, or we can leave the toString off because it gets invoked automatically. Now when we run it, we should see that it prints out two shapes. One for Bob the square, one for Bob the circle, and the other for Sally the square. And it should print their areas as well. And there we go. A shape with a radius of 10 does indeed have an area of 314. A square with a side of 10 does indeed have an area of 100. So that's not too different than what we did before. But like Adrian asked, why did we make it abstract? It's because we just wanted to guarantee that if somebody else came along and started adding other shapes, triangles, hexagons, whatever, that they would know exactly what they had to implement in order to get it to work. Now, strictly speaking, our shape class could have contained the name variable. And why do I say that? Because every class we've implemented so far has a name instance member. And if you find that to be true, if every single class that you are creating has a variable, probably a good idea to go ahead and move that up into the abstract class. I don't know, let's do that. Let's take that private string name, cut it out of the square class, or comment it out, whatever you want, and go and put it in the shape class. So what I did is I took our private string name instance variable, I'm cutting it out of square, I'm going into shape and pasting it there.
Does that have to be abstract? No?
Alright, I got an error there and I just accidentally fixed it. Not sure how I fixed it. I clicked on the error without understanding what it was doing. But similarly, right, we don't need set name here. Set name did not have to be abstract in this case. Kind of regretting making this change because I did see that error come up. I clicked something to make it go away. I think I'm going to undo my changes. No, I'm not. I am going to move set name into the abstract class. So I'm cutting the whole thing out of square, saving it, going to the shape class, and it's no longer going to be abstract, so I'm just going to delete that line. But it's no longer an override because this is the parent class. This is the superclass for the rest of them. Alright, so now we have a string name, which I need to make private even though I did not. I think I've just goofed. I deleted the wrong method. Let me undo some of that stuff. Alright, what I did is, you see get area, that's the one I deleted. What am I really trying to replace? The abstract method here. I'm not going to replace it at first. There, you see that? Abstract method, override, but it's not an override. We're putting the method right here, so I'm going to delete those two lines. This is our new shape class.
Well, what was the point of making public void non-abstract?
Just because, yeah, why did we do that? Because all of our subclasses did have a string called name, and therefore all of our subclasses need something called set name. So we're taking that stuff out of the subclasses and we're moving it into the parent class so that everybody can use it. That way when we go and we implement a square and a circle, it's less coding. All they have to do is implement get area and hopefully toString. Alright, I hope that didn't make the example more confusing. I kind of did it to show you that an abstract class can have data, and it can have non-abstract members.
Okay, can you go to your square class real quick?
Okay, so I'm going to go back to the square class.
And we'll see your set.
I seem to be getting an error down here.
Those names
Okay,
are-
here's my problem. It says name has private access in shape, so I do have an error going on here. And why is that? What does private mean?
It's only accessible in its abstract.
Right, private means that this variable is only accessible within the current class and not even its children classes. So if I want to make it private but allow my inherited classes to access it, I need to make it protected. That gets rid of that error in the square class. So you see what I did? I went to the shape class. I changed the word private to protected, and I did that so that the square class and the circle access still have access to the instance variable. If this was private, they would not. And why do they need access to it? Because our toString is using that variable. All right, the circle class still has its set name and its name member. I'm going to get rid of those as well. So I'm going to the circle class. I'm getting rid of name because it's defined as its superclass now in shape. And I'm going to get rid of the @override set name. And there we go. Now they are both. Both of these classes are equivalent. They don't redefine anything that didn't need to be defined. If we had any other variables that were going to be shared between every shape, we should put them in as instance members of the shape class as well. All right, let's make sure it runs still after those changes. And there we go. Printing shape list. Bob the circle is that. Sally the square is that. Do I need to go and create more shapes? No, but I do want to show you something. And this is a little bit of a problem. Not a problem, but it's something to be deeply concerned about when you implement this kind of thing. Go back to your client code, and after we print out our shape list, let's change the names of our shapes. And then let's add those to it again. Or let's not even add them. So we still have C1 and S1, right? So C1.setName is now called Freddy. And S1.setName is now called Becky. Now print out the shape list again. I'm just going to copy that code. Paste it here. Alright, so this is still inside my client code. This is the first time I printed out the shape list. Then I changed the names of the objects. Now I'm printing out the shape list again. And it says Freddy area is equal to 314 and Becky area is 100. Maybe that makes sense to you. Why is that happening? Because when we add things to our shape list, it's not putting copies of those shapes in there. It's putting originals of those shapes in there. So if we go in and then change them later, that changes the data. We're not even having to access the array list in order to change those elements. We're just changing the original values of them. It's like you have a school bus full of kids. You know, you go in and you change the names of the kids. The school bus has the same kids. They all just have different names now. That's probably a really dumb example. But the container here just contains the objects. And if you still have references to those objects, you can access them directly like that. And you may not have expected that to change the stuff inside the shape list. But it does. Just be aware of that. And what would you need to do if you didn't want that to happen? Is perhaps clone the objects, make copies of the objects as you before you insert them into the shape list. All right, let's go back and check the PowerPoint. So here's their example. They created an abstract class called employee. I like shapes, books like people. Don't know what that says about me. So abstract class employee, every employee has to have a name. And so they have some getters and setters for it. But then they're going to declare as an abstract method something called getPay. Now why is that abstract? Because you can have different kinds of employees whose pay rate is calculated differently. Salaried versus, hourly. So this is going to be abstract. So anything that inherits from the class employee is going to have to implement the getPay. And there's some stuff further down. Yeah, you can scroll down to see it if you want. So then on the next one, surely they show us using that class. Yeah, thanks. They don't show us using that class. So in order to use this class, we would write another class, like hourly employee. An hourly employee would look a little bit like this. You know, you certainly don't have to type this in, but you know, public class hourly extends employee. And what does it have to do? It has to have its own abstract double get pay override, or else it will not compile. So at override, you know, public double get pay, and in our weird world, all hourly employees earn $100, whatever, like that. Of course, this class would be considerably more complex than that. They create a constructor for their employee class. So if you're going to make an hourly employee, it should pick up. Let's go back and add constructors to our classes here. And I did not mean to launch Visual Studio. Alrighty, so let's add a constructor to the shape class and see if that takes care of the circle and the square class. So I'm going to go to the shape class. I'm not going to make this thing abstract. I want it to be an honest-to-goodness constructor. So public shape, and all it's going to take is a name, string name. This dot name equals name. I seem to be getting an error. What have I done wrong? Oh, I just put this before the curly brace. Abstract public class shape, curly brace, and here's our constructor. That's going to break our code though. Circle and square have problems. Let's go see why. This wants a constructor as well. What if we hadn't defined the other one as abstract? Would we be able to get away with not creating a constructor there? Well, don't know, but let's go ahead and add a constructor for the shape class. I'm kind of disappointed we have to do this, but no problem. Public circle. It doesn't even accept any parameters. But what does it do? It calls the super constructor with the word circle. Now we could make this one take a string, right? So that we could actually give the circle a name like Fred or Bob or whatever. Just kind of showing that we are free to implement different constructors here as long as they call the superclass's constructor, the abstract class's constructor. And as a matter of fact, let's make a really good constructor that sets the name and the radius of it. Alrighty? So string name, comma, double radius. The first thing it has to do is it has to call the super constructor. Super, passing in the name, because that's what that class is, the super class's constructor requires, and then we can set this radius equal to the radius that's passed in. Now we're going to need to do something very similar to the shape class. It also needs a constructor that invokes the superclass as the parent class's constructor. So let's go do that. Go to the square class, add a constructor. Public square. It's going to take a name, string name, and it's going to take a side length, so double side. First thing it has to do, the call to the superclasses constructor always has to be the very first thing in our constructor. So call super, pass in name, and then we can set this dot side equal to side. This has broken our client code, by the way. Why? Because if you provide a customized constructor or parameterized constructor, the default constructor is no longer available. So when we go back to our client code, we're going to have to fix it so that our constructors pass in these variables. Or we could turn around and create a default constructor, which would look like this. Public, square, do nothing, you know, and then when it was time to, you know, super, we could call this, you know, the unknown circle. Yeah. I'm going to delete all that. I hope you didn't type it in. Okay. So go back to our client code. And here we go. We don't need to call set name and set radius anymore. That's going to be done automatically. I'm going to comment those out for now. So when we call new circle, his name is Bobby Circle, and his radius is 10. Same for square. Square S1 equals new square, quote, Sally Square, with a side length of 10. And I can comment out those setter calls, mutator calls. And heck, now that I've sat there and stared at them for 5 or 10 seconds, why don't I delete them? All right, there we go. Constructors always make the code look cleaner, right? So I like it. We could even add some more shapes on the fly. Let's add a few more shapes. I'm going to go down underneath the two dot add calls, shapelist.add, parentheses, new square. He's just going to be called square 3, comma, and he's got a side length of 5. Hope that syntax is clear. Now when we print them out, we're going to see 3 squares. And the third one's going to have the boring name of square 3. This is called an anonymous object. Why are anonymous objects good? So that you can't accidentally come back in and change values in them. Right now, the only way to get a hold of this third object is to actually get it from the shape list. So anonymous objects like that are actually a good thing. All right, and there's our third square in our output. All righty. Protected access modifier. We've learned about that. Protected means that you can access them from your children classes, from your subclasses. But the client code, nobody else can, except you or your subclasses. When to use protected? When you want a member to be directly accessible from any class within its tree of classes. So here we have, you know, a manager, a laborer, a secretary, and they all extend employee. Then somebody comes along and they create executive and middle manager that extend a manager. Now, if you want all of these to have access to the employee's name, then you would declare name as protected. But if there's something that's absolutely private to the employee class that you don't want these guys to be able to change, like maybe the, I don't know, the employee ID or something, I don't know, then you would make it private rather than protected. Usually you can get away with making everything protected, or you can get away with making everything private and then changing it as you need it. And that's probably the better solution. That's a better version of encapsulation. Alrighty, so what is the name of the class that is the superclass of all other classes?
What is the name of the class? Oh, the object class.
Yeah, object class is the superclass of all other classes. And I don't care which animal classes. Alrighty, dynamic binding is also called late binding. And what does that mean? Well, when the code calls, let's go back to our code. When our code calls getArea, which right now nothing does, but we could, we could add up all the areas of all of our shapes, then that is a overridden method. And it's got to figure out where that overridden method is. setName is an overridden method. No, it's not actually overridden, but it's in the parent class. So when we call square.setName, that's actually located in the shape class. And Java has to figure that out. That's called dynamic binding, because it needs to figure out in which class. I'm sure if we do Control F and we look up dynamic binding, we'll get a definition of it. Just before Java executes a method call, it looks at the method, it looks at that object, and it tries to find where the appropriate version of the method is. It binds that method to the method call and then executes that bound method. And so that's late binding. Happens at runtime. So a superclass dummy method can be used to satisfy the compiler when your intention is to call same name methods in the subclasses. What type of method is the elegant alternative to putting dummy methods into your class, into your parent class, your superclass? And that's an abstract class. I like this answer, stylishly intelligent. All right, I think this is about done. The last thing to talk about with inheritance is the idea of interfaces. And an interface is an abstract class that's got a special property. In Java, unlike C#, C++, C++ allows you to extend more than one class, inherit from more than one class. Extends shape, comma, whatever. Can't do that in Java. You can only extend one class. But there's another kind of class called an interface. And you can make your code extend, or more properly, they call it implement, as many interfaces as you want. And so we'll talk about why that's a good idea. You could have a animal. You could have a dog that's both an animal and it's a patient of the vet. And so you could define an animal abstract class up at the top, but then you might want to say, oh, okay, I also want it to have every attribute of the patient class. You make that patient class an interface so that, then you can, put the animal's weight in, take its temperature or whatever. Don't know if that's a great example, but we'll talk about interfaces in a future lecture. What's coming up next is exception handling, which is incredibly important, and we probably shouldn't wait until chapter 15 to do it, in my opinion. Not sure why the book does that. Probably because when you create exception handling, you can derive your own classes. You can use the exception classes as your base classes. All righty, any questions? All right.